Hey, lesson 3.5, graph a line using intercepts. All right, intercepts. We have dealt with those in con. Okay, intercepts are where the lines cross the axes, where a line, any graph of a line crosses the axes. So that would be called your y-intercept. This would be called your x-intercept. And that's what we're talking about today. We're going to graph lines using intercepts. Well, to graph lines using intercepts, we have to be able to find the intercepts. And that is the main focus of today's lesson. We'll add to it with a second lesson about the same subject. All right, so today we're going to find coordinates for the x and y intercepts. All right, hopefully you remember how to solve equations because that's going to be a big part of this. All right, and also graph the line using the x and y intercepts. That's the easy part. Okay, finding what they are is the hard part. Although you guys are pretty good about finding the y-intercept, we just need a method for finding the x-intercept. Okay, so let's just do this. Please pause and copy this down. Copy it neatly. Notice how my line goes right across one of these lines, and then I go up to each of the lines in my paper, okay, and then I draw ones halfway along, and I try to make these lines exactly the same distance. Not perfect, but you have to be as neat as you possibly can. Okay, we have 3 lines here, and what we're doing is this is just to kind of intro to hammer home exactly what intercepts are. Okay, so let's focus on line 1. We're going to follow that line and see where it hits the 2 axes, the y-axis and the x-axis. All right, the x-intercept is right here for line 1, and that coordinate pair is we start at the origin, and we always walk to get to the elevator. Okay, when we walk over, that would be negative 1, 2, 3, 4, negative 4, comma 0. All right, we don't have to go up at all. So our x-intercept is left 4, up 0. X-intercept, left 4, up 0. Okay, now we're going to look at that same line and see where it crosses the y-axis to get our y-intercept. That's right there. And that one, when we start at the origin, we don't have to go at all to the left or right. We just go straight up. So that's up 1, 2, 3, 4, 5, 6, 7. So that's going to be 0 left or right, and it's going to be 7 up. All right, see if you see anything that's always true about the x-intercepts and always true about the y-intercepts. All right, that's one of the keys and one of the key properties that we'll use for the rest of the lesson. Okay, remember, when we write coordinates, the x-coordinate tells us to go left or right. The y-coordinate tells us to go up or down. All right, that's just a little hint, tip, reminder, more so a reminder. Okay, now we're going to line 2. So that's this guy. He has a negative slope, but we don't really care about the slope right now. We are looking for the intercepts. So let's find the x-intercept, which is where it crosses the x-axis. All right, so we're looking for where line 2 crosses the x-axis, and that is right here. So for our x-intercept, we start at the origin, and we go left 2, but we don't have to go up or down. We just go left 2, so that's 2, 0. Look at this x-intercept. Look at this x-intercept. What do you notice? What do they have in common? Okay, now let's look at the y-intercept. So we follow this line 2 up until it crosses the y-axis. Bingo. We got a point right there. We start at the origin. We say, we don't have to go left or right. We just have to go up. 1, 2, 3, 4. So that's going to be 0, 4, right? We don't have to go left or right. We just go up 4. All right? So notice what do these 2 y-intercepts have in common? All right, and line 3, I bet without even looking over here, you could figure out half of each of these answers. What do you think? What do you think? Do you know one of these numbers for the x-intercept? Well, look up here. 2, 0, negative 4, 0. So I'm guessing that it's going to be something, 0 here. Let's go check on that. The y-intercept of line 3. No, sorry, x-intercept of line 3. Where does it cross the x-axis? The line cross the x-axis right here. All right, x-intercept. And that is over 1, 2, 3, 4, 5, and up nothing. So it's over 5, but up nothing. So we were right about that. How about the y-intercept? Are you predicting that the first coordinate is going to be a 0? The x-coordinate is 0? All right, well, let's check. So where does this line cross the y-axis? It crosses it down here. If we start at the origin, we go left to right, nothing. We go down 1, 2, 3, 4, 5, 6, down 6. So we were correct. That should be a 0. All right, so let's summarize this. Please copy this down. Make sure you have this key concept in your notes. The key concept here is that x-intercepts, for all x-intercepts, the y-coordinate is always 0. Okay, because the x-intercept, if we go over here, these 3 x-intercepts, how far did we have to go up or down for them? 0, right? Because it's on the x-axis. So the y-coordinate is going to be 0 because you don't have to go up or down. Okay, and then if we move over down to the y-intercept, the blank is always 0. I could bet you can figure it out. The x-coordinate, right, is always 0. And if we look at our 3 y-intercepts, we don't have to go left or right. We only went up or down. So therefore, from the origin, we don't have to go left or right. So that means that the x-coordinate is 0. All right, you can see that here. See my y-intercept? X is 0. Y-intercept? X is 0. Y-intercept? X is 0. X-intercept? Y is 0. X-intercept? Y is 0. X-intercept? Y is 0. That is our key concept. We're not done. We're using that key concept to do our objective today, okay? To find coordinates for the x and y intercepts. All right, so what I'm going to do now is I'm going to give you an equation, and you're going to use that equation to find the intercepts, all right, by thinking about this key concept. So let's give it a shot. All right, so finding the x and y intercepts from equations in slope-intercept form. All right, so that says intercept. All right, if you can't see how I spelled it, look it up. Slope-intercept form. So this is the easier of the ways because you already know how to find the y-intercept. All right, so write this down. Example 1, find the intercepts for the graph of y equals 2x plus 3. So if we were to graph this, make a table, plot some points, and drew it, we could see where the line crossed the y-axis, but we already know because of what we've done in past lessons, y equals mx plus b, right? That is always going to be your y-intercept. So step 1 is just to find the y-intercept, and we already know it, okay? We just find the b in the equation, right? Find the b in the equation. All right, so that's our step, and in this case that's going to be 3. Now remember, the y-intercept is going to be 0, 3, right? Because for all y-intercepts it's going to be up or down, so you don't have to go left or right. Okay, only up or down for those y-intercepts. So the x-coordinate is always going to be 0. Okay, so that's step 1. Just by looking at the equation in slope-intercept form, we can find that y-intercept. Step 2 now. Step 2 is find the x-intercept by substituting, underline that word, substituting. Just like a substitute teacher comes in for your teacher and replaces them, we're going to substitute in 0 for y and solve. Okay, so this is what we do. First, we write the original equation. Now, for all x-intercepts, remember our key concept here? All x-intercepts we know half of the answer already. Okay, all x-intercepts are going to have a y value of 0. Okay, we already knew that. We already know that because they're going to be on the x-axis, so that means you don't have to go up or down at all. So y is 0, the y coordinate. So what we're going to do is we're going to use that. We're going to plug that in for y. Okay, we're going to plug that in. We know that that y is going to be 0. So then we just simply solve this now that we substituted in 0 for y. So our first step is to sub in 0 for y. And then our second step is to solve for x. All right, and how do we do that? Well, we use inverse operations. Minus 3, and we get 2x equals negative 3. And then we go divide by 2, because it's multiplication, divide by 2. And we get kind of a weird answer here of negative 3 over 2. Or you could simplify that down and be negative 1 1/2, comma 0. So that's where it's going to cross the x-axis. That's our x-intercept. So now we have our two answers. We have 0, comma 3 and negative 1 1/2, comma 0. All right, what our goal is to take those 2 points, plot them. All right, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay. The y-intercept would be 0 over 3 up, 0 over 3 up. And the x-intercept would be negative 1 1/2. So that's negative 1 1/2 right in between there. And then we just connect those two with a nice, draw a line, a straight line through. And that's how we do it. Okay, so what do we do? Well, we know the y-intercept because of slope-intercept form. Then to find the x-intercept, we substitute 0 for y and solve. Substitute 0 for y and solve. All right. Whew. Try this one on your own and see if you can get it. All right. So step 1, we just use slope-intercept form. Y equals mx plus b, and we got to find that b. So y equals 1/3 x minus 2. Bingo, negative 2. So our first step is to find that y-intercept, and that's going to be 0, comma negative 2. Okay. Step 2 is to plug in 0 for y. So we have y equals 1/3 x minus 2. We're going to substitute in 0 for y, 1/3 x minus 2, and now we're going to solve. So we get plus 2, 1/3 x equals 2. How do we get rid of a coefficient that is a fraction? We multiply by the reciprocal. That cancels, leaving x behind, and we get 6 equals x. So our x-intercept is going to be 6, comma 0. If we were to graph that, okay, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 1, 2. 3, 4, 5, 6. All right, we got a very rough graph here. If I plot this at 0 over down 2, that's right here. And 6 up, 6 over, 0 up. 1, 2, 3, 4, 5, 6. And there's my line. Quick. Okay, let's go. Now we have to introduce something new. It's called standard form. Copy this down, please. Find intercepts for the graph of equations in standard form. What is standard form? Standard form is, instead of y equals mx plus b, it's ax plus by equals c. And a, b, and c have to be integers. That means no decimals allowed. Okay? And a has to actually be positive. Which it just says here, it says that in a short way. a is greater than or equal to 0. So that means it can't be negative. Okay, it doesn't have to be positive. It could be 0 as well. But anyway, here we go. So, and a, b, and c are integers. So therefore, you can't have like 1.5a plus, I replaced a with 1.5. Sorry, x plus 2.6y equals 7. Okay, because those aren't integers. You have to have something like this. Full whole number there that's greater than or equal to 0. This can be a negative, and this can be a negative. Okay, but these numbers can't have any decimals, and this one has to be positive. All right, that is official standard form. Now, we're going to find the intercepts for the graph of 2x plus 3y equals 18. Okay, we're going to find the intercepts. So if we want to find the x-intercept, plug in 0 for y. Okay, and solve. Okay, and then for the y-intercept, plug in 0 for x and solve. Write small, fit it all in there. You can do it. All right, so we write the original equation here, x plus 3y equals 18. And since we're finding the x-intercept, what did we find out? What did we find out was interesting when we plotted those earlier? The beginning of the lesson, that every single time we found one, the y value was 0. So we can use that information to help us. All right, so we have this. We have 2x plus 3 times 0 equals 18. Well, that can be simplified. What's 3 times 0? It's 0. Okay, so you get 2x equals 18. Why? Because 2x plus 0, this is 0. Okay, so it's cool because one of the terms will cancel out completely, and all you have to do is divide at the end. All right, so that kind of cancels out. You have 2x equals 18. How do you solve that? Divide by 2, and you get x equals 9. So we plugged in 0 for y, and we got out x equals 9. So when y is 0, x is 9. There is our x-intercept. Now we do kind of the reverse over here. We have 2x plus 3y equals 18. And in this case, we plug 0 for x. Plug in 0 for x. So we got 2 times 0 plus 3y equals 18. And you can see why people like to use standard form when they're finding intercepts. Because look, 2 times 0 is 0. And we have 3y equals 18. Just have to divide by 3. Y equals 6. So we substituted in 0 for x, and we have y is 6. Okay, so now we have our intercepts there, and we could plot those 2 points on a coordinate grid, strike a line through, and have our graph. Our line would be graphed. All right, let's try this one, you guys. Try to do it yourselves. All right, here we go. So to get the x-intercept, plug in 0 for y. For the y-intercept, plug in 0 for x. All right, it's weird because the opposite of, you're looking for the x-intercept, so you plug in something for y. But you'll get the hang of it with some practice. 2y equals negative 10. So we're finding our x-intercept, so 0 for y. 5x plus 2 times 0 equals negative 10. This basically cancels out, so we have 5x equals negative 10. Divide by 5, x equals negative 2. So what's our coordinate pair there for the x-intercept? Well, we plugged in 0 for y, and we figured out that when y is 0, the corresponding value for x is negative 2. So that's the coordinate of where the line for this equation will cross the x-axis. Let's do the other one. 5x plus 2y equals negative 10. And in this case, y-intercept, we plug in 0 for x. So 5 times 0 plus 2y equals negative 10. And that basically cancels out. So we get 2y equals negative 10. Divide by 2. Divide by 2. Y equals negative 5. And we plugged in 0 for x. And y is negative 5. There we have it. That was slightly longer than I might have wanted to do, but I think you guys might get it. 20 minutes of math. So fun.